All right, let's finish up the last page of the study guide. So we have two types of problems here. We've got work problems, so 27 and 28, and then some maximum profit problems for 29 and 30. So I'm going to jump right down to 27 here. Let's see what we've got here. We have Kayla, and we have Kristen, and they are washing cars. So let's get together for a total here. All right, so Kayla's rate, she can wash a car, so one car in 13 minutes. Kristen can wash the same car in 14 minutes, so one car in 14 minutes. How long would it take them to work together to wash 3 cars? So my total here is going to be 3 cars. And for time for Kayla and time for Kristen, that's the thing I don't know. I don't know how long it's going to take them. So I'm going to give them X for both. And there's my plus sign. All right, so for this particular problem, I'm going to figure out my LCD. So least common denominator here. Now, currently my denominators are 13 and 14. So to find a common denominator, I can just multiply those together. And 13 times 14 is 182. So I'm going to take that LCD of 182 and multiply it times every part of this problem. Now, you'll notice I have Desmos up and running as my split screen because I'm going to guess I'm going to need it. All right. So let's see. 13 goes into 182 14 times. So it's going to be 14x. Plus 14 goes into 182 13 times. So that's 13x. And 182 times 3 is 546, because that was not going to happen in my head. All right, so 14x plus 13x is 27x, and that's equal to 546. I'm going to divide both sides by 27. So x is equal to, well, let's see, what's 546? Whoops, let me actually get all the numbers there. 546, there we go, divided by 27. So 20.2 repeating. So I'm going to do 20.22, and this is minutes. All right. So if Kayla and Kristen work together in a little bit over 20 minutes, they would be able to wash 3 cars together. All right, I'm going to go ahead and slide over to number 27. Nope, that was 28 now. All right, working alone, it takes, okay, so we've got Maria. It helps if I actually spell names right correctly. All right, so Maria plus Shanice, and we're going to work together to get a total here. All right, so let's see here. Working alone, it takes Maria 12 hours to pick 40 bushels of apples. So we're going to do 40 bushels in 12 hours. Shanice can pick 60 bushels in 9 hours. If they work together, how long would it take them to pick 70 bushels? So 70 is my total, and again, I don't know my time, so we can do x and x for time for both of them. Let's see, my two denominators right now are 12 and 9, so the LCD, now I could take 12 times 9, in which case I would use the common denominator of 108. I actually know that there is a smaller denominator that works, so I'm actually going to use the LCD of 36. Now, if you did use 108, mathematically, you will end up with the same answer that I do at the end. Your work will just look a little different. All right, so I'm going to take that 36 here, I'm going to multiply by 36 here, and 36 here. Okay. So 12 goes into 36 3 times, so I'm going to have 3 times 40x. Let's see, 9 goes into 36 4 times, so I'm going to have 4 times 60x. And I have no idea what 36 times 70 is, so conveniently I'm going to use Desmos. 2520, so 2,520. Let's see here. 3 times 40 is 120x. 4 times 60 would be 240x. Equals 2,520. Let's see here. 120x plus 240x is going to be 360x. Yeah, that sounds right. 2520. We're going to divide both sides by 360. So x is equal to, let's see, 25 2520 divided by 360. That's an even 7. So this is 7 hours. All right. So if the two people work together, it would take them exactly 7 hours to pick 70 bushels of apples. All right. So those are the work problems that we've been doing. Let's talk about some maximum profit problems. All right, 29. Charter company, $400 per passenger, 50 or fewer. For each passenger in excess of 50, the fare is decreased by $2 per person. Charter's expenses totaling $21,000. Okay, so we've got a profit equation. All right, what should be the number of passengers over 50 to maximize the charter's profit? And X is the number of passengers over 50. So I'm actually going to go through Desmos really quickly and delete all of this other stuff. Not that I think it would interfere with anything, but I'm just going to delete it all. And I am going to put this profit equation into Desmos. I'm going to slide over just a little bit, so I have plenty of space here. All right, so 400 minus 2x, whoops, helps if I put all the pieces in the right places. Then we're going to do 50 plus 1x. I don't know why I just put a less than sign. There we go. Minus 21,000. Okay, so now I want to take this graph and basically keep manipulating it until I can find, there we go, the top of it. All right, so my maximum point, because I'm trying to maximize the profits here. So my maximum point is 75, 10,250. So this is X, which is the number of passengers over 50. So how many passengers over 50? You should have 75 people. All right, that's a pretty straightforward one. So 75 in this case is the number of passengers over 50. All right. So that one is now done. Number 30 is kind of a similar question. It's another profit one. I'm going to slide Desmos over so I can get the problem a little bit better. 40 cars rented at a rate of $31 a day, $2 increase in rental, 1 car is not rented. Okay, so we have another profit equation here. So this is the number of cars, and this is the price, okay? So it's asking what should be the price per day to maximize the profit. So we're gonna actually be trying to figure out this piece of the puzzle. So I'm going to take that, let me eliminate what I had in there from Desmos, and I'm going to put in the new one. So 31 plus 2x times 40 minus 1x, and then minus 540. Now the nice part is because I'm already working with Desmos, it was already large enough to see this. If you wanted to, you can zoom out. I'm looking for that maximum point. All right. Now, one of the things to keep in mind with these problems is X has to be a whole number. All right. So because X has to be a whole number, I want to take this X value and round it appropriately. So in this case, we're going to say X is equal to 12 because 12.25 would round it down to 12. And I want to take that X value and use it in this expression. So 31 plus 2 times 12, and I'm going to use Desmos to make my life pretty easy here. And since it's up and running, I might as well. So 31 plus 2 times 12 is going to be a total of 55. So the charter company could or should charge $55 a day to maximize their profits. All right, so that's the last problem in the study guide. If you have any questions or concerns about anything, please let me know. The test is coming up next week, so make sure you are ready.